Hey, what's up, YouTube fans? So this one I wanted to talk about in this video, right, is how it is, right, that we can say with great precision and confidence the chronological order of the evolution of the bodies and genomes of various living things, all living things, including humans, right? Step by step by step. So, these parts before these parts and these parts before those parts, the chronological order, and we can get a good idea about what at various stages along the way was the body setup, right, of the earlier progenitors, right, leading up to the living things we have today, right? And so, I mean, how could that be the case that we could get a precise idea of that? It's not clear at all if you just look at the human body alone. It's, there's, I mean, you could imagine tons of random possible ways that we could have evolved to the point of how we are now. It would be entirely unclear where it starts, where, what are the steps. If, it would be very unclear if we just look at humans alone. You could to some extent say like, oh, this part relies on this part to work, so therefore this part must have been evolved first. You could to some extent say that, but looking at the human body alone, we will be very clueless about it. We get a very precise and clear idea, though, when we take it into the context of cladistics, right, which is where we study which groups of living things are most closely related to each other. So we study clades, right? A clade is a group that includes a common ancestor species and all of its descendant species, and which doesn't include anything else. That's a clade. And so, every species on the earth today is part of clades, which are themselves part of larger clades, which are themselves part of larger clades, and so on, ultimately tracing back to the last common ancestor of all life, right? And so in any event, clades will oftentimes have features common to all members of the clade, or common to most members of the clade, right? And which are distinguished from other groups, right? And this can give us a good idea. This can help in recognizing clades and in understanding the order that various features were evolved, right? So, for example, mammals, right? Mammals is a large clade that we're a part of. And, I think most people don't realize just how many traits that they have specifically because they're a mammal, and which they would not have otherwise. People will think that being a mammal just means you have hair and that you produce milk and give live birth, but there's a lot more to it than that. For example, the fact that we have exactly 7 cervical vertebrae, the neck vertebrae, that's a mammal trait. That's true of almost all mammals, no matter how long the neck is. Even giraffes, right, with their extremely long necks, they have 7 cervical vertebrae, just like me and you. And, rodents with their short necks, they have 7 cervical vertebrae. The only 2 living exceptions to this amongst mammals are sloths and manatees. All the rest of the thousands of mammal species have exactly 7 cervical vertebrae, right? Whereas there's a lot more variance of the rest of the vertebral formula. even like eastern lowland gorillas and western lowland gorillas do not have identical vertebral formulas, right? Even though they're both gorilla species, but we consistently see 7 cervical vertebrae in almost all mammals, but we don't see this in other groups of tetrapods like birds, reptiles, and amphibians, right? Other living groups of tetrapods, right? And then it's also because we're mammals that we have 3 middle ear bones, right? Whereas other tetrapod groups have just 1 middle ear bone. And it's because we're mammals that we have 1 lower jawbone. And it's because we're mammals that our teeth are specialized into incisors, canines, premolars, and molars, which is not the case for most other vertebrates, right? And most other vertebrates have more than 1 lower jawbone. And it's because we're mammals that we have a diaphragm and a 4-chambered heart and an epiglottis and a neocortex. The neocortex is found in all mammals and only mammals. And it's because we're mammals that we have not just mammary glands, but also sweat glands. It's because we are mammals, that specifically therian mammals, that we have external ears, right? Only mammals have external ears. Nothing else does. No bird, no reptile, no amphibian, none of them. And it's because we're mammals that we're warm-blooded. Most other groups are not warm-blooded. So, there's a long list. It's because we're mammals that we have craniostylic jaw suspension and a secondary palate. So, there's a long list of features that you have specifically because you're a mammal, which we would not expect you to have otherwise, right? And the same can be said of other clades you're a part of, like tetrapods. It's because you're a tetrapod that you have eyelids that blink and a tongue and a stapes, and your vertebral column is specialized such that you have cervical, sacral, and coccygeal vertebrae, and your ribs form a cage with a sternum, and you have a choana, and it's because you're a tetrapod that you have carpals and metacarpals and tarsals and metatarsals and digits with phalanges, and you have 3 pelvic bones. So there's many features you have because you're a tetrapod. There's many features you have because you're part of a group of primates called the catarrhines. It's because of that you have the dental formula 2123, 2123. We find that in all catarrhines, including humans. And it's because you're a catarrhine that you have downward facing nostrils, whereas the New World monkeys have sideways facing nostrils. And it's because you're a catarrhine that you have trichromatic vision, whereas most other primates have polychromatic vision. And it's because you're a catarrhine that you do not have a grooming claw, which is something we find in many other groups of primates aside from the catarrhines. And there's so many traits you have because you're part of the vertebrate clade. It's because of that you have a skull and a backbone and camera-like eyes and a liver and a pancreas. It's because you're a vertebrate that you have your brain specialized into front brain, midbrain, and hindbrain, and each of those specialized into regions unique to vertebrates. And you have a closed circulatory system with endothelial lining and blood made out of red blood cells. All of that is because you're a vertebrate. Also, another feature you have because you're a mammal, specifically a therian mammal, is that you don't have a cloaca, which we find in monotremes, reptiles, birds, amphibians, and many groups of fish, which is a single hole used for peeing, pooing, and reproducing. You don't have that set up because you're a therian mammal. And because you're a therian mammal, you have a philtrum, the little indentation between your nose and your mouth. We don't find that in other groups aside from therians. And it's because you're part of the chordate clade that during embryonic development, you have notochord and postanal tail and dorsal nerve cord. So these are just some examples, but you know, these aren't the only clades you're a part of. We're part of a long list of clades. So you know, our species Homo sapiens is part of the larger hominin clade, which is part of the larger great ape clade, which is part of the larger ape clade, which is part of the larger catarrhine clade, which is part of the larger anthropoid clade, which is part of the larger primate clade, which is part of the larger boreotherian clade, which is part of the placental clade, which is part of the therian clade, which is part of the mammal clade, which is part of the amniote clade, which is part of the tetrapod clade, which is part of the sarcopterygian clade, which is part of the osteichthy clade, which is part of the gnathostomic clade, which is part of the vertebrate clade, which is part of the chordate clade, which is part of the deuterostome clade, which is part of the bilaterian clade, which is part of the eumetazoan clade, which is part of the animal clade, which is part of the pisthocont clade, and which is part of the eukaryote clade, right? And so you're part of all of those clades, and then you're part of the clade that includes all life on Earth, even bacteria and archaea. You're part of all of those clades. You know, most of those clades along the way, I could tell you characteristics you have because you're part of that clade. For many of them, I could tell you several characteristics. And so in any event, because we find that living things are organized into these groups with shared traits not found in other groups, often several traits distinguishing the group, we therefore can get, and then those groups are part of larger groups and so on, we therefore can get a very good idea of the chronological order with precise, you know, very, very great precision and confidence, the chronological order that various features were evolved, right? Now it's not a perfect understanding, you know, because, for example, with mammals, there are many features of mammals, and so we can get an idea that, like, oh, well, these features evolved after we split from reptiles, but you know, what was the order of this features specific to mammals that they evolved? We can even with that get a decent idea with a lot of it thanks to the fossil record. There are many transitional fossils from reptile-like mammals to modern mammals, mammal-like reptiles to modern mammals. There are many transitional intermediates like the gorgonopsids and, you know, Dimetrodon. But, you know, that will mostly inform us on the skeletal evolution, you know, certain things like the neocortex, the diaphragm, four-chambered heart, things like that is going to be more difficult to piece together from fossils. So to some extent, we can't get a perfect idea of the chronological order that the features were evolved, but we can get a very precise understanding, though, much greater than you would necessarily expect if you didn't understand cladistics. And, you know, these patterns were observed long before the theory of evolution long before Darwin was even born. Carlos Linnaeus, all the way back in the 1700s, he was observing these things. He's the father of taxonomy, right? So, kingdom, phylum, now we have domain before kingdom, but not back in his day. Um, and really now the amount of categories that we have is vastly more than just like the simple, what you get from like domain, kingdom, phylum, class, order, family, genus, species. That's a good start. That's a good start, right? But that's only like the very rudimentary basics. It really skips over so much, right? Like you have like that system goes right from uh what is it to like it goes right from chordate down to mammal, right? And as I showed, right, there's so many steps between those, right? So I mean that's a very basic system compared to like modern cladistics, right? But that gives you a basic summary. But so even back then, before we had an understanding of common descent, before Darwin, these patterns were observed that, living things, for whatever reason, reasons not apparent by their lifestyle or environment, they were grouped into different groups with shared traits, several shared traits oftentimes, and then those groups within larger groups and those groups within larger groups and so on. Back then, they didn't understand why, but they did observe this pattern, right? And so even back then, they were starting to classify these things, right? Once Darwin came along, right, and once we understood common descent, right, then there was a lot more clarity and understanding as to why this would be the case. All right, that's all for now. See you guys.